Okay, so we have heard about Scott's satellites and the Loon project as ways to provide networking. Even though Loon is supposed to be low cost, that might still be a bit pricey for individuals to do this in their backyard. So I want to speak a bit about a slightly lower cost version that everybody can afford, at least in relatively wide areas. And so about building networks yourself, if you talk about low cost, that also doesn't necessarily mean that we want to compete on a global scale. So our down-to-earth version of neighborhood networking deliberately constrains our initial ideas to your local proximity, your vicinity. Also to keep content that you might want to share roughly where it matters. So we do have lots of cool cloud services in the internet where our data move halfway around the world to be maybe retrieved, maybe not retrieved. So we collect a lot of data waste in the internet. We also cause a lot of data to be moved between routers, which costs a lot of energy, even though quite often you just try to talk to your neighbor. And so we may have examples of where we might go to music festivals, campsites, into the woods somewhere, or just to talk to build residential networks between between houses in the vicinity, and we might be using DTN as mechanism to interconnect those. And so I want to talk about two things today. One about a cheap, inexpensive networking platform, mostly made of DTN-compliant software, and then about ways of sharing applications and types of applications that we want to share. So let's start with networking platform. So it starts out in this case from the more developed world, where we do have mobile phones and other mobile devices that share and offer connectivity, for example, through Bluetooth or wireless LAN. And while our planets fly quite predictably, and also satellites move quite predictably across the world, even the balloons can be placed predictably. As soon as we start relying on people to carry data around, things become less predictable, since we don't necessarily know where they're going to go. So we call the whole thing opportunistic networking, to reflect that we have always a certain an element of uncertainty in the whole thing. So assuming that you want to exchange messages with others, not tiny internet packets, but sizable messages that can carry images, videos, or whatever, if you want to do this and have information interchange between people, we first of all need to discover that somebody is there. If we meet somebody and have found that a bunch of people are nearby who carry similar devices, we might want to engage in communication. So if I have taken a picture here and I run into somebody who also happens to be carrying such a device, I might want to figure out that this person exists, set up a connection, format my message into a DTN message, into a bundle, and forward this to this person. If I have a group of people standing somewhere else, I might be lucky that this person is going to move around and carry that piece of content to this other group so that it can spread among those people as well. And so since we can't quite know how people are going to move, it may take time. We have talked about 5 minutes RTT. It may take an hour until a person whom I have given a piece of content to meets the next person. The person may go to nowhere, turn off the phone, drop it by accident into water, and our message disappears. So we are having something which feels a bit like an internet because it's best effort. And obviously our networking performance and connectivity is going to depend on how many people I have around, how densely they are, how they move, how regular, how predictable, and a bunch of other features. So I can't really easily build reliable networks in the sense of a predictable internet where I have relative certainty that the packet is ultimately going to make it somewhere. So we have to think about mildly different networking abstractions, and we came up with a number of different ones that we want to use. Whenever devices are close by, when one might even engage into direct IP-based communication, but if you want to have message exchanges across larger distances, we are looking at relaying, store, carry, forward messaging, like we have seen for the space scenarios earlier today. Now things are a bit less predictable, so we don't really rely so much on point-to-point communication. Research has shown that trying to send something from somebody in a city to somebody else in the same city turns out to be highly difficult to guarantee message delivery at some point. So this notion of sending something to somebody kind of doesn't really make so much sense. Rather, we take a slightly more information or content-centric approach and declare interest, that we are interested in certain pieces of information that we would like to collect, and so subscribe to what other people might publish, and then get information delivered. And this can be realized by actively searching for things, so similar to a Google search, broadcasting, asking everybody around you, or passively collecting whatever other people have and whom you meet, because the system assumes that the owner might at some point care. We built different abstractions and different protocol systems about that. But I don't want to go into all these technical details into too much depth. The result, in the end, is what we have been developing is a small Java platform that runs on Android devices as well as on embedded systems, Linux, and so forth, that offers a device-independent core and then some platform-specific APIs to build applications on top. And these can be native applications coded, for example, for the Android operating systems. But nowadays, if we want to enable broader sets of people to actually design applications, we need to consider what people nowadays use. Typically, they use the web, so we offer also an HTML5 interface. You can just write little HTML5 JavaScript stuff and use those to build your applications, just to make it accessible to a broader community. And in addition, we offer a small app distribution mechanism. I'm going to come back to that in a moment. Now we have these devices, but if all of us have devices here inside this room and we leave this room, then whatever we have been exchanging here is going to be spread out, disappear, and somebody who comes an hour later is not going to be able to retrieve this. So we may need to invest into a bit of infrastructure beyond the plain mobiles. Mobile device-to-device communication is tricky to begin with because our vendors and operating system manufacturers haven't so far managed to get a decent device-to-device ad hoc communication system into place without requiring jumping through hoops and or routing devices. So that's tricky anyway. Even if that worked, we need to bootstrap from somewhere, and we don't necessarily want to rely for our little neighborhood network that we might want to set up anywhere on an internet platform. Just mentioned already that people may leave, and so you do whatever with their devices, they might run out of battery, so there are bad places to store data on that we might be interested in. So from that perspective, it might also be nice to have something which is a bit more reliable, a bit more stationary. And so we came up with this idea to build a very tiny low-cost infrastructure, essentially Raspberry Pi, can easily be powered by some battery thing. This runs probably for something between 24 and 48 hours out of the simple battery pack, and so can be easily used on any kind of excursions. This thing essentially features a wireless LAN access point, including a captive portal, like we all know this from wireless LAN hotspots, except that it doesn't offer internet access, but it offers downloading stuff. The whole system costs this thing about 80 euros, this battery pack another 30, so fairly low cost and quite affordable. This functions as a router to store, forward, and replicate information. At the same time, it is a storage device, and it can mesh with other of these instances as via overlays across the internet, but also because people walk back and forth between them in a continuous stream. So if you happen to have an Android device, you could actually look for a wireless LAN that is called Liberouter and connect to this thing right now. There are a bunch of applications I'm going to talk about in a moment. So it offers you, as somebody who has an Android device, this little router functionality as an Android application that can be downloaded and run on the device. At the same time, also a bunch of native Java applications. We have 3 on them for download right now. And not in this specific distribution here, a bunch of HTML5 stuff. We are also experimenting, because not everybody would wish to install something on the devices, legacy access, for example, for poor iOS users, gaining access to whatever information is on that system using the web content interfaces for browsing, and have been playing with all kinds of other tricks. The whole idea behind this thing is people probably do have mobiles, so we need to enable the rest. And so put up a component list, building instruction for configuration and everything, additional data like, for example, instructions on how to do 3D printing for the covers, and also the software all online, so that one can go to a single place and download whatever you want to get for your next camping excursion, and build your small little network inside the woods. If you should go to this website to this device right now, you're going to see a website that looks roughly like this. Liberouter as a name, then there is on the left-hand side the router software itself, and then here we have 2 applications. The current installation that is running here has 3. And yeah, from there you can download and install this on your Android without any effort. This installing without any effort gets us actually to the second point I want to make, namely sharing applications. If you are in the woods somewhere, then you can't rely on the typical application distribution infrastructure as there are today. Either we see web-based application where everything comes in JavaScript from your respective web page, or if that isn't the case, you go through an app store as a mediator between people who are offering applications and those who want to get them. Both is not really useful if you are somewhere where you don't have internet connectivity, so the whole system must become more self-contained. And what we are doing is essentially taking a step back and wait a second, an application is nothing more than a bag of bits. So rather than putting this bag of bits somewhere on the other side of the planet for somebody to download, it would be even as useful to have this in a signed DTN bundle that you can then install. And so we have a little Scampi apps mechanism. Scampi, by the way, is the European project that funded this, where people can publish their own applications that they have been writing into the DTN network that can be autonomous in the community, from which others can then download those applications, install them, and utilize the same network of other devices to run them. And I want to say a few words about the applications that we have been building, but I want to start with one general observation, namely remembering that this is not the internet. So we don't have this end-to-end instant connectivity. You ask for something and within 100 milliseconds or so you're going to get a response back. So that's nothing that we could possibly compete with. First of all, distance matters. The further somebody would have to carry a message, naturally the longer it would take for that message to be received. And the higher the probability would be that your message might never make it. And we don't hear instantly or ever back whether something succeeded or failed. So there is no point in competing with the internet. We need to build upon different paradigms. And that typically boils down to, since users aren't willing to wait for something, we always try to think of this as applications scanning for data that might be of interest in the background and offering a user whatever they have available when the user asks for it. And this allows us to build applications where we don't require 100% reliability, where any gain that we get over nothing is already something valuable. If we are close to one of these centralized little systems here, then we can probably build slightly more reliable applications, but for the general case, we would be trying to be truly best effort in the internet sense. A couple of applications that we have been looking at for this purpose that fulfill this are, on the one hand, a simple messaging application just for people to exchange short notes with each other. We also have built in the past a voice messaging thing that allows you to do recordings. And we have something called Gorilla Pics, for which I took a couple of pictures and uploaded this to our little server here earlier this morning. That offers simple picture sharing. So that would be possible, for example, to document whatever you see around, share photos with your friends, and so forth. Since we have been talking quite a bit about earthquakes and other things, we also built a distributed version of the Google Person Finder using roughly the same information that can be used in a completely ad hoc fashion without any need for an infrastructure. So these things could collect some parts of the data. There might be another thing put up a kilometer further down some way that might collect another subset. And as people move between those, they would kind of exchange and complete the database and allow you to make annotations about what people have been found, whom you are seeking, whom you are searching, and so forth. So this is just one small set of examples of applications that one can build. I'm happy to talk about further details afterwards. Now this is surface of the Earth. One can go even further down, and we can build those little boxes also in a bit more rugged fashion and think about not thinking just about little Android devices, but maybe about more robust machines. And so we have been taking this to underground mines. We are deploying a mine which is a perfect example for a disrupted environment. No radio waves propagate through the walls, and wherever people are blowing things up, you can't install network infrastructure. But you want to get sensor data from the machines. And so we have in northern Finland an installation running in a mine where we are using trucks that go through these dark mines. So this is actually a picture from this very mine that carry messages back and forth in a semi-commercially integrated setup with the mining system to collect data, and we actually can improve the retrieval and accuracy of information that's available in the control center of that mine quite substantially, even with a few trucks going around. So this is a different way of looking at terrestrial networking using DTN, and another wonderful application area that one can use. To sum up, the whole idea behind this little router box is exploring ways of networking without internet dependency and building things that can sustain themselves and form little ecosystems wherever you want them to be. They can grow in a kind of meshed, fully meshed, partially meshed, either via backbone connections, via wireless long-range links, or just because people or other things go back and forth. And we can use that to share information for all kinds of different applications. We are looking at more different outdoor applications at the moment. Especially we are looking at mobile application authoring, so that people who are in this community can actually use their mobiles to also create new applications using kind of templates and then simple authoring tools. And then we are looking at something more sophisticated where people can, for example, do something like Google Docs in a distributed fashion in this kind of environment. And so all the stuff is online, so if you want, try this at home. Thanks. Questions? Yeah. Viruses. Wonderful example. Yes.
I'm thinking it seems a lot like unprotected sex. A lot of people added to the message.
So what I didn't mention is that we actually do have security mechanisms in place, but you're completely right. In a distributed setting, you don't have the friendly guard that checks your centralized system, that checks your email for incoming viruses. So we are looking into recommendation systems, and we are looking into questions. So the moment you can establish authenticity of who has been building an application or who has been sending a message, you know whom you are going to trust. Since we are not talking about a huge anonymous crowd, we are talking, after all, about a relatively constrained group. So the fact that somebody is going to send an application that you would be unwillingly executing without knowing whom it comes from, that can to some extent be prevented. But otherwise, this is one of the biggest issues that you would experience if you don't build in some reasonable security. Yeah. Bob.
Yeah, so just continue on that. I worry that your early adopter for the application distribution will people who run compromised applications. The NSA, for instance. Well,
So actually, one of the ideas was to kind of fly a bit below the radar of the NSA and not to use the internet infrastructure for some of these elements. But yeah. Okay. So try this out. I'll leave it running for the rest of the day, and if there's further questions, please let me know. Thank you.